Good morning, everyone. Welcome to today's presentation on Network Essentials. I'm Aparna, an assistant professor in the Department of Computer Science and Engineering at Swami Vivekananda Institute of Science and Technology. Today, we'll be exploring the fundamental concepts that form the backbone of computer networks. We'll cover key topics such as network types, protocols, and security essentials. I'm excited to guide you through this subject and hope you find it both informative and engaging. Let's get started. All right, let's dive into how the TCP/IP protocol handles data transmission. Once the packets are ready, IP is responsible for releasing them onto the physical medium of the network, meaning it hands off the data to the hardware that physically moves it around. A key part of this process involves the IP address, which is divided into two main components, the network ID and the host ID. The network ID tells us which network the destination device belongs to, and that's crucial for routing. If the destination device is on the same network, then the host ID helps us pinpoint the exact host within that network. However, if the destination is on a different network, then the source device's TCP/IP stack doesn't send the data directly there. Instead, it sends the packets to a default router, which acts as a gateway. The router then takes over, guiding the packets toward their ultimate destination across different networks. This process highlights how TCP/IP efficiently manages data transfer, whether the destination is local or remote, ensuring that information reaches the right place through proper network identification and routing. Now, let's take a closer look at how routing works in a network. When a packet arrives at a router, the router's job is to figure out which network to send it to next. This decision depends on the destination address contained within the packet. The router might send the packet directly to the destination network if it's connected to it, or it might pass it along to another router that's closer to that destination. It's important to understand that sometimes, a packet has to pass through multiple routers before reaching where it needs to go. Each of these steps is called a hop. Think of hops like checkpoints along the journey of a packet across the network. This process is fundamental to how data travels across the internet and networks, ensuring that information finds its way efficiently from source to destination. It highlights the critical role of routers in managing data traffic and maintaining smooth communication across different networks. Let's take a closer look at network essentials, starting with TCP/IP. This is the fundamental protocol suite that underpins the internet and most networks today. It enables different devices to communicate reliably across diverse networks. TCP, or Transmission Control Protocol, is all about ensuring that data is transmitted accurately and in the correct order. It manages the connection between sender and receiver, making sure everything arrives intact. IP, or Internet Protocol, handles the addressing and routing of packets. It's what directs data to the right destination based on IP addresses, acting like the postal system of the Internet. Together, TCP/IP forms the backbone of network communication, providing the necessary protocols to support reliable data exchange. This understanding is crucial as we explore more advanced network concepts later in this chapter. This slide is part of our broader discussion on how networks operate seamlessly, and TCP/IP is central to that. It's what makes modern digital communication possible, connecting devices around the world efficiently and effectively. Now, once the data packet reaches the destination network, the process of locating the exact host begins. The host ID part of the destination IP address is used to identify and find the specific device we're trying to reach. Think of it as the final step in pinpointing the exact location within that network. When the packet arrives at the destination host, the host checks the IP address in the packet. It accepts the packets only if the destination IP matches its own address. If it's a match, the host then removes the IP headers and hands the data over to TCP for further processing. This is where TCP comes into play. TCP will verify the checksum in its header. That's a kind of integrity check to make sure the data wasn't corrupted during transit. If the checksum matches, TCP considers the packet valid and accepts it. But if the checksum doesn't match, it indicates that the data may have been damaged, so TCP will discard the packet. And here's an important point. In that case, TCP will request that the sender resend the packet. This process helps ensure data integrity and reliability, which is essential for accurate communication across networks. This entire sequence ties back to our overall theme of understanding how data travels reliably from one device to another using the TCP/IP protocol suite. Now, once all the packets have been validated and accepted, TCP steps in to do its part. It uses the sequence number to carefully recombine the packets back into the original message. Then, it looks at the port number to ensure the data gets sent to the correct application, whether that's FTP, Telnet, HTTP, or another service. To manage networks effectively, we organize them into a logical set of layers. Each layer has a specific role and provides certain services to the layer above it, while also relying on services from the layer below. This layered approach helps keep the network organized and makes troubleshooting and management much easier. And an important point to remember is that each layer on one host communicates with the corresponding layer on another host through a set of rules we call protocols. Think of these protocols as the language they use to understand each other. Finally, each layer communicates with the layers directly above or below it through a defined interface. This structured interaction ensures smooth, reliable data transfer across the network. All of these concepts tie back to our overall goal of understanding how data moves seamlessly across networks. Thank you so much for your time and attention today. I really appreciate your engagement and interest in what we've discussed. As we've seen, understanding these key concepts can truly make a difference in how we approach our work and challenges. Remember, the ideas we've shared are all about creating better connections, improving efficiency, and driving growth. I hope you leave here inspired to put some of these insights into action. Once again, thank you for being here and for your commitment to continuous improvement. I look forward to seeing how you apply these ideas moving forward.